In this lecture, we describe the quotient rule. The inverse operation to multiplication is division. Division reverses the multiplicative process, so it's no surprise that the product rule can lead to a rule for quotients. The quotient rule we're getting ready to describe is going to look similar to the product rule in some ways. We won't derive the quotient rule here, but we'll merely state it. Suppose I have two differentiable functions, f and g, and suppose g is not 0 at x, then I want to look at the quotient f of x divided by g of x, and its derivative. The derivative of f of x over g of x is this fraction on the right. The numerator of this fraction is f prime times g minus f times g prime, and the denominator is just the square of g. So the derivative of f over g is f prime g minus f g prime, all divided by g squared. This formula is one of the rare results that's worth memorizing. I don't memorize very much, but I remember this formula by asking myself, how do I view algebraically dividing, having a denominator as opposed to multiplication? We can often view division by g as multiplication by g to the minus 1. Notice that exponent, minus 1. So I can think of the fraction f over g as the product fg to the minus 1. This suggests that when I differentiate g in this expression, I should remember to multiply it by minus 1. So the numerator in this expression looks like the product rule, with the one exception that we subtract the term where we differentiate the denominator g. Then the new denominator is just a square of the old, for reasons beyond our discussion here. So here's the formula. Now I'm going to think of it a little bit differently. Let's have u divided by v. What's the derivative of u divided by v? The answer begins by, first off, put v squared in the denominator. Before you get started at all, make sure you have a denominator. It should be v squared. And then I'll worry about the top. Now, the top looks like the product rule, except that blue plus sign is wrong. I'm going to need to change that to a minus. So there is the quotient rule. The denominator is v squared, the square of the old denominator. The numerator looks like the product rule, except that when you have the piece where you differentiated v prime, that piece is subtracted. Again, let's go back. I'm going to take the derivative of u divided by v, square the denominator first. Then remember the product rule, but remember to change the sign. The two big results in this lecture material, earlier we saw the product rule. The derivative of fg is f prime g plus fg prime. And here the derivative of f divided by g is a fraction or quotient, f prime g minus fg prime, all over g squared. Let's practice these. Suppose you're given this expression and you want to find y prime. We have a product of two terms. The first one is 2 plus x to the minus 1, and the second is x to the 3 half plus 1. By the product rule, we're going to do this. In red, I've simply put down that I want to differentiate something. So the product rule says differentiate this 2 plus x to the minus 1, write down x to the 3 halves plus 1, write down this piece, then write down the earlier term that you differentiated, 2 plus x to the minus 1, and then differentiate that other piece. So all I've done in this line is announce what I want to differentiate. Now, in the next line, I'm going to differentiate the things in red. So the derivative of 2 plus x to the minus 1 is minus x to the minus 2, and the derivative of x to the 3 halves plus 1 is 3 halves x to the 1 half. I can now expand this expression a little and write the denominator as a combination of powers of x. In this expression, I have x to the minus 2 times x to the 3 halves. That's going to give me an x to the minus a half. We'll have minus x to the minus a half. Way over here on this piece, we're going to have 3 halves x to the minus a half. Together, that will give me 1 half x to the minus 1 half. And then the other terms come out in various places in the product. So here's my nice simplified answer. You should always try to simplify things if possible. If you simplify things, then things are simpler. Here's one more practice problem. Suppose we want to take the derivative of e to the t over e to the t plus t. By the quotient rule, we're going to get this expression. Again, I'm just announcing here in red that I intend to differentiate this part. So this is the derivative of the numerator, this is the denominator, minus, now write down the numerator and plan on differentiating the denominator. In the next line, I do my derivatives, and then I clean up the numerator a bit to get this expression, which is this expression, and there's the cleanest term I can get. In the next presentation, we will use this quotient rule to find the derivatives of the 6 trig functions.